And now for the legal stuff. Hi folks, thanks for tuning in. This is Gary Reed here with Addy Machinery coming to you from Clinton Township, Michigan. I know you can't see it outside today, but it is a beautiful day, and I had a little bit of free time here in the shop. Been out there getting ready for an upcoming lunch and learn event that we're going to have, and I realized that it's been quite some time since I have posted a video, but there's good reason for that. Had a lot of activity here since the last video that I posted, and I believe the last video was actually the Metal X system, all three pieces of equipment being uncrated, and kind of showing everybody that process and giving everybody an idea as to what that equipment looked like. And I guess it's been about a month since then, and one of the reasons why it's taken so long for me to get back to you with the next video is because our building wasn't quite ready for the installation of the Metal X system. We purposely held off doing our electrical and ventilation upgrades until we could get all three pieces of equipment in here, particularly the center one furnace and the washing station. We wanted to do a nice job. We wanted to have that equipment here so we could lay everything out, get the spacing right. Obviously, this is a show place for us, but we also wanted to show our customers and potential customers what they will be up against should they decide to purchase something like that. But I am very happy to say that we are now operational. All three pieces of equipment have been installed, and we're going to go out onto the showroom floor here in a few minutes and take a look at the installation, particularly the wash one and the center one. I'll be getting more questions about those two pieces of equipment than anything rather. And I just wanted to show you here. This is the very first metal part produced on the very first operational Metal X system in the state of Michigan. And we're going to be doing a close-up of this part here in a couple of minutes. Let's see. So, questions. We've been getting a lot of questions about the wash one and the center one specifically. The Metal X printer is, an FDM style printer. Obviously, it's not the same as the kind of printer that you would see behind us here, but people who've been doing 3D printing are familiar with the FDM process, and other than a few twists and turns, that process goes about the same. What seems to have everybody concerned and asking questions is the wash one and the center one. A lot of questions about how hard is those two pieces of equipment to operate, and how much room do they take up, and people wanting to see my setup, the way I've got everything set up there, so that they would again know what they would be up against should they decide to purchase a system like that. So we are going to be going out to the floor in a couple of minutes, and we do have another part that is in the furnace right now, and that's going to be done here within the hour, and hopefully it's actually printing another copy of this wrench right here, but we've done a few things to that to improve the surface finish slightly, and we'll talk about that just in a second. Stay tuned. Okay, so here's some important things that I wanted to share with you about this first part that we produced. So I hope that this shows up fairly well on the video there, but the surface finish on this is not bad at all. And there's been absolutely no processing done to this part whatsoever, either pre-center or post-center. So it will be easy to improve the surface finish of this even more, since it is metal, by running it through a tumbler, by doing some polishing to the part. Several things that we could do to this component, since it is now a metal component, in order to improve that surface finish. And as far as post-process machining, that is also possible as well. Now keep in mind, the Mark Forged process, the walls, and the floors and the ceilings on this part, those printed solid, but there is interior infill on this part. So, you know, this is not printed completely solid, but you could take several thousandths of material off of the floors, ceilings, and walls in a post-process machining application. So that's something I wanted to share with you. We do have a test part in the furnace, this exact component that is in the furnace, but I did some sanding to that, some wet sanding to that part in the green state, just after it came off of the printer, while it was still in that clay-like state. And when you do that, that is going to improve the surface finish, and we'll be able to compare and contrast that to this component here in a minute. I also wanted to talk to you about this piece of material here. This is the actual, what they call the raft that the wrench printed on. You can actually see the outline of it here on the raft. And the raft is very important, because this is what helps the component to shrink at a uniform rate. Because now you've got this nice smooth surface here that is going to be laying against that nice smooth ceramic plate, and during that heat process, that's going to allow the entire part to shrink at a nice even rate. And you can see this outline here on the raft, okay? And that outline is actually where the release material printed. There is another dissimilar material to the 17-4 stainless that is printed in between the raft and the bottom of this component here, and that material is designed to get very hard, very brittle during the sinter process, so that the component can break loose very easily and very cleanly. And just so you know, everybody wants to check the size there. It came in very nice size-wise. Very happy with that. Get that oriented there correctly so everybody can see that. And overall, very happy with the part. And we're going to be going out here to the showroom in a couple of minutes to take a look at the equipment and take a look at the other component that has been green sanded. So stay tuned. Okay, so I'm going to stand behind the camera here. I think it's going to make things a little bit easier. I apologize for the noise in the background, but what you can see here, I'm going to get a close-up here on the clock. And we've got about 5 minutes left before it's going to be okay for me to open up the chamber. So while this thing is finishing its cycle, I'm going to do a quick walk around to the equipment. So this here obviously is the center one furnace. Okay, this is our tube furnace, and we've got this sitting on a 5-foot table. And if I kind of back out here a little bit more, the whole system in between these beams, it measures about 20 feet. So you're going to need a good 20 feet in order to lay everything out and have everything spaced so that you can get out there and have room to walk in between the equipment, service it, so on and so forth. Okay, we're going to move up here to what seems to be causing the most concern for lots of people who are looking at this equipment, and this is the gas setup that we have here. The large device there to the left is a liquid argon dewar, just it's a pressure vessel. This system does require quite a bit of argon gas, and the most effective way to produce lots of argon gas, or lots of any gas rather, is using a pressure vessel, using a dewar. So the big device there on the left is where that is supplied from. The next bottle there is going to be your backup bottle of argon gas. Basically, if your dewar there on the left, if it runs out in the middle of a run, you're going to have enough material there in that brighter red gas bottle there to finish your run, so you won't lose your part. And then the other two bottles there to the right, those bottles are your mixed gas, and that is a combination of two gases, argon and hydrogen. Again, those are mixing gases that are also applied at the appropriate time by the furnace during a center run. So the device here up top, this is the mixing gas rig, and there's a cable that is connected between the center one furnace and the gas rig itself, so that way the system can actually keep track of gas usage and whether or not you actually have enough gas to complete a run, so on and so forth. So it's monitoring all that as the machine, as the oven rather, is in operation. And you see those hard lines up at the top there. You're actually hard piping that gas, your inert gas and your mixed gas, over to the back of the machine there. Kind of see the back there. Get a close-up of this. And of course, there you see the antenna. This equipment is hooked into our Wi-Fi system. You can monitor this remotely. And then the other tube here, right there, that is where your exhaust gases flow up and out of the system, and we have that tied into our ventilation system there. I want to back out of here just a little bit. This is the hatch here on the end. We'll be opening that up just in a minute. This is where you load and unload parts. And our ventilation system, both of these pieces of equipment, the center one and the wash one, both those require 100 CFM of ventilation each. So I think I've got a minimum 100 CFM. I think we've got like a 300 CFM fan that's feeding this system right here. And you'll notice that, interestingly enough, you don't even have to have that tube sealed off there. That is just literally just a piece of 3/8 stainless steel tubing that is stuffed 6 inches up inside that ductwork there in order to draw out any waste gas that comes out of the system. The wash one is a big industrial degreasing unit, essentially. Uses a special fluid, Opteon debinding fluid. And if we go in here and open this up, let me get my flashlight. Sorry, I'm moving everybody around a lot. Open this up. That is actually boiling down inside that chamber. We got to keep this lid closed all the time. So this is the very critical second step in the process. You take your green part, put it into the washing station, wash it for an appropriate amount of time, and the software will tell you, Eiger will tell you how long the part actually needs to wash, and then you move it over here to a drying station. And once again, Eiger, there's no parts in here right now, but Eiger will tell you how long the part needs to wash. And then once dry, how long the part needs to dry. And then once the part has been washed for appropriate length of time and dried, and we've weighed it, and we know that the appropriate amount of binder has been removed, then it is okay to take your component and put it over here into the furnace. And the furnace is extremely easy to operate if you've got everything set correctly. If you have all of your gas inputs, that rig and everything set correctly, and everything is set right on the furnace, everything is sealed properly, all of your filters and everything have been seated properly, and there are no leaks in the system. It's going to go through numerous checks before it actually kicks on and does a center run, but basically you turn it on and the software takes care of everything else. You don't have to worry about, you know, any kind of calculations as far as how long you need the part to be in the furnace. The software is going to take care of all that. There's no guesswork as far as when to apply gas and how much. The machine takes care of all that on its own. So from that regard, from that aspect, it is very easy to operate, and so is the washing station for that matter. Basically, you just follow the guidelines established by the software, weigh your part appropriately, and as long as you're following those guidelines that are very carefully outlined by Mark Forged, you're going to be just fine. So I see right now that the furnace says it is now cooled. So I'm going to put down the camera, I'm going to open this up, and we're going to see how we did. Okay, so I went ahead and shut the fan down so that it wouldn't be quite as noisy out here. Gone ahead and taken the bolts loose, and put on my Kevlar gloves because we're still at about 90 degrees C on the interior of the furnace here. So open this up, reach back in here. By the way, I did go ahead and pull the radiation shield out. Went ahead and did that. So now the component sits on this ceramic plate on the interior of the unit there, and that is what allows it to, one of the things that helps it slide nicely inside there. The raft slides nicely against this to help it shrink at a nice uniform rate because there's nothing binding up on it. And you know, again, the surface finish is definitely not bad, and this part's almost too hot for me to hang on to right now. But I think I could do better. I think I could do better. The lines that are on the other part are gone, and it definitely feels smoother. But this is sort of like experimentation for me as well. Still trying to get a feel for the system and what I could do. You don't want to go too aggressive when you sand, because there's a chance you could mess the part up when it's in the green state like that. Now you can see right here, there's the release material, and it's on there quite well. So we're going to give this just a little tap against the table here and see if we can get this to break loose. There you go. Just kind of breaks loose. That just turns to absolute powder right there. You can see some of that powder on the back. And again, I'm happy with the surface finish. I'm happy with the way the part turned out. The surface finish is better, but we could get it a little bit better. So maybe on the next video, what I'll do here, I'll do a little bit of post-center processing to this, and see if I can't get this thing shining like a new penny. So thanks for watching, and I'll see you next time.